Hello again, it's Luke Darksnout here, and in this episode of Backbit Impossible, I am still trying to figure out the most confounding thing, the biggest bug that this project has ever experienced. And, here I am, with less than 3 hours sleep, thinking it's a good idea to go at the computer and try to figure this thing out, and that's exactly what I'm doing. So I'm not really thinking clearly, I'm not speaking very well, but nonetheless, there I am, because sometimes you know how it is. You can't sleep until you find a little bit of peace, or at least give it your all. And when this episode is over, well, I guess I finally do get a good night's sleep. More like a good morning's sleep. Anyway, let's watch. Right, it's nearly 4 a.m. I had a thought that, well, I guess I rolled over in bed and, anyway, check it out. There. The white is the raster interrupt. As you can see, it's a solid line here. Very solid, because those are the instances where it isn't updating the color. And this is the subroutine where it updates the color and then leaves. So if I run it again, you still see the green on the wolf here. Well, and lots of other stuff. Now I was thinking perhaps it takes too long occasionally, and maybe it does, but I also had it set so how do I explain this? The current buffer, after it loads fills frames 0 or 1, 0, 1, 2, 3, 4, and then it takes the current buffer number at that point and puts it in the background color. And it was usually green, which is, or was it yellow? Which is 7. So it was already at 7 by the time it finished, you know what I mean? I thought maybe it was like almost time to wrap, and it wasn't. So this mystery remains a mystery. This time, the white is, let's look at the wolf. Okay, it's still corrupted. The white is the time where the wait delay is happening on the back bit, queuing up data. I wonder if that had anything to do with it. I mean, if I turn it to 20 megahertz, that should make a difference. It doesn't. But it sure makes a big difference in whether or not we get the color corruption. I am still puzzled as hell. Because when it's finally done, when it comes back from the wait delay, that's when it begins filling the buffers, with rolled out code. But it'll start filling buffer 0 or buffer 5, right? 5, 6, 7, 8, 9, 0, 1, 2, 3, 4. And if it's filling buffer 0, it's already over here. It's probably around buffer 6 or 7. And when it's filling buffer 5 at the beginning, it's already at buffer 3 or 2, maybe 1. It's nowhere near where the action is, and yet it's enough to cause it to make interferences. I don't get it. For my next trick, all the 53272 values are now this. Obviously in the first video bank, and I'll show you what 53272,70 does. It solidifies the screen as that. And the only thing we're going to see is the color differences. But hey, I can still assemble it in this position. And once it's done, it's going to start flowing. Now, it should be still screwing up predictably, and it's really hard to tell, isn't it? Let's look for the green on Mr. Wolf here. Oh, yeah, because now it's, as you can see, look at this, it's multicolored. that really makes a mess of things, doesn't it? Well, I might have to choose a different value. Or I could fudge a solid block setup so I can just see the colors alone. Let's try that. All right, so now character set is at 0800, video matrix 0400, of course. I have part of my initialization clearing out 0800 to, well, to 1000. So my program is going to be toast the moment I run it. But here we go. It just should be solid squares. And we still get, well, this one's a good way to see. And I did see the green on the wolf there, which is not part of the image. This is the same video, 20 megahertz. What? Oh yeah. My program's entirely erased. Well, I can't show you, but adding one screen refresh to every interrupt and there's no color glitching. That is still the biggest clue. Look, he's nice and clean. Everything's clean. I mean, this is one of the situations where if I simply slowed my video down to this frame rate to make it work and called it a bug fix, it's not a bug fix because I don't understand why it's doing it in the first place. You see what I mean? I need to know. It has to make sense to me. Otherwise, I'm just cheating by slowing it down. But I've thought of a way, well, I guess if I do it, it's a waste of time, but I'll show you anyways. I'll tell you. This is one character set. Well, if I slow the frame rate down, I could make it 2 and have just a raster interrupt in the bottom or in the middle switching from one character set to the other. But the trick is the 40 characters in this middle stripe are the same for both character sets. So the top half and the bottom half each have 216 characters unique to that section of the video. So we have 2, 4, and video matrix 5, compressed color 5.5. So you have 5.5K per frame to bring in at a slightly reduced frame rate. Might look much more pleasing than the staticky, you know, how it's flickering with color glitching. But I need to know why the color is glitching anyway. Okay. I gotta get back to bed. It's almost 5 o'clock. I probably should have saved this before I began running it. I have completely gutted, like removed the raster interrupt, the main loop, waits for the bottom, slams down the next frame, and it's smart enough to know when it needs to do new buffers. Look how intermittently smooth it is. So then this is at 20 megahertz. So let's turn it down. Interesting difference. It's no longer smooth, but it only does a frame, like, you know, it only initiates a frame when it's down here. Kind of cool. I don't think you're going to get color glitching this way. Too bad I can't even break out and restart it. I should have saved it. But yeah, I know why it's kind of intermittently, like it moves, stops, because the frames aren't updated by interrupt. So when it does need to fetch new buffers, that's all it's doing. And then when it comes back, it waits for the bottom to do the next frame. So the little snippets of time where nothing seems to be moving is when it's fetching buffers, which, and if I turn it up to 20 megahertz again, you see those times, those delays are still there because it's still stepping aside to fill the buffers. And that still takes time. But other than that, it kind of looks like soap opera. It's probably doing it at 60 frames after that, but it can't do 60, well, maybe 30. You know what I mean? I bet you it's close to 60, but because of the buffers, it's not. So if I took away the cue, if I took away the part that brings in new data after the initial, I could probably get it cycling 10 buffers at lightning speed. 5:10 in the morning. Another thought to go on. These are my color buffers, right? I can just break out of the program, load up my monitor, and there they are. So what I can do is grab these, like I have them. Like, let's start at the 9,000 here. What do we got? See, they all point to 5. That's set color. 7, set the color. Set the color. 1D, set the color. You can see, so one buffer is going to connect to the next, because in some certain sequence, because I don't know where the split is, well, it would never be here. It would be, well, it might be here. Depends when I do my check. No, it's only going to be here or here. But I can work it out and see how one frame connects to the next. And kind of like a little puzzle, and piece it together, because this logically should continue the flow. You know what I mean? Like, I should never have stranded bits that don't make sense. And what I can do is stop it during that crazy time. As soon as you see the green, maybe stop it and check that out. Maybe. Because, well, I could simply do it slow and then do it fast, like normal speed. Because there's a difference, right? When I'm running it with extra time in between the frames, the corruption doesn't occur. But when it's a 2-3-2-3 pattern, you almost always get it. That's what I can do. Maybe in the morning, I gotta get to bed. Man, but thanks for coming with me on this debugging nightmare. Wow. It's after 5:30. I had one more thought on my way to bed. Take a look. Only the green on the wolf is there. Tell you, it'll be so satisfying when I figure this out. Well, lunch was $11.54, 64 cents. But I think I solved my problem. I'm going to go home, and this sucker is going to work. You won't believe it. It's convoluted, but I believe this is why it was screwing up. I tell you, this is probably one of the best ways to end an episode, eh? After all this most confounding thing nonsense, banging my head against a wall, I basically announce that I've solved it, and I leave it like that. Ha! But did I really solve it? Because, I mean, I haven't tried this yet. In the next episode, I go home and see if it truly is the solution. Find out next time on Backbit Impossible.